Hello and welcome to another Roblox tutorial. In this video, I will show you how to make this cool laser reflection simulation. This is based off of a Roblox showcase I did a few days ago. If you haven't watched that, make sure to check it out. This tutorial is not for the faint of heart. It is quite complex with a lot of vector math, a lot of raycasting, and some interesting loop mechanics. But I hope you guys enjoy this video. Make sure to like and subscribe if you do. And let's get started. So this tutorial is going to be a little bit different than the laser showcase video. And the only differences are going to be that the laser will not animate because the animation is fairly complex and will make this video overtly complex because what I want to do for this tutorial is just make the laser fire appropriately and just work. The animations are just some flair. If you want to see the animations, then comment down below, and I will make a separate tutorial just for that. And I'll also have optimized it a little bit and just added some extra stuff. So let's go into the workspace and create a module, and this is going to be the brains of our laser, and I'm going to name this laser. This will be our laser module. Also in the workspace, I'm going to create a folder, and I'm going to name this folder laser beams, one word. And then I'm going to go back into my module. Instead of having the normal module variable, I'm just going to say laser because it makes more sense. And then the first variable I'm going to define is the laser beams folder, which will be equal to workspace, wait for child, laser beams. There we go. And now I want to define some variables that we will use later, and these can be customized by each laser module that you instantiate. And so these are going to be laser.max distance. So this is going to be how many studs the ray for the laser will go. I'm going to set mine to 50. You can customize these to your liking. And it's going to be and the next one is going to be laser.radius. I'm going to set this to 0.5. This is going to be the width and the height of your part that you spawn to represent your laser. And then I'm going to make laser.max reflections is going to be how many times a laser can reflect. And the reason we have something like this is to prevent our laser from bouncing infinitely, which will crash your script and your Roblox, maybe. And so after this, the first function that we want to define is a basic object-oriented function, and this is laser new. So function laser new. First thing we're going to do in here is set self underscore index to self, and then we're going to return set metatable brackets and then self. There we go. So what this does is this is a basic object-oriented function. If you don't know what object-oriented programming is, and I have a whole series about that, you can check that out. It's in the description. And this basically just creates a new instance of my laser class. And that's all we really need for object-oriented programming in this whole thing. And the reason I'm doing something like this is so you can create a new laser class and customize all of these. So many scripts can make many lasers, but they all don't have to have the same parameters, or they all don't have to share the same parameters when they change it. So that works really well. And now let's start with a visual function. This is going to be laser show beam. This is going to be responsible for creating the laser beam part. And it's going to take in two parameters, the origin and the direction. And this is origin and direction of the ray, of course. So the first variable we are going to define is the middle vector. I guess we could name this midpoint. That'd be a better name. Midpoint. And this will be equal to the origin plus the direction divided by 2. And I explained this all in my how to make rays visible video. I will make a card to that right now and hopefully link it in the description if I remember. And now that we have our midpoint, that's really the only coordinate we need. And it's pretty easy from here. We just basically make our part, and then style it a little bit, and then position it and orient it and create its size, of course. So we're going to make our part, which is going to be instance.new part. And we're going to first set the part.parent to the laser beams folder. There you go. So part.parent equals laser beams folder. And the part.anchored value will be set to true. And then this is all just for style. I'm going to set the part.material to enum.material.neon. And I'm going to set the part.brickcolor to brickcolor.new really, not really black. Let me just get this up again, really red. There we go. So this will create a part in the workspace, probably at 0, 0, I assume. And it will set all of these properties. So now we actually need to position it and resize it. So the way we're going to position it is we're going to set this part.cframe to cframe.new. And the cframe we're going to use, like the constructor that we're going to use, is position, then look at. So the position that we want our cframe to be in is the midpoint, and what we want our cframe to look at is the origin. So it'll be oriented at the midpoint, it'll be positioned at the midpoint, and it'll look at our origin vector. And it'll make it orient in the right direction. The only problem is on the roll axis. So like if it like side to side, it won't really change, like depending on the look at. And that's probably not a big problem, but just keep that in mind. And so now all we need to do is set the part.size, and this is pretty straightforward. We're going to make a new vector3, vector3.new, and for the x and y, we're going to use self.radius, and then self.radius. So this just defines the width and the height, and since whenever our part looks at something, the z is the size, is like the face that looks at it, we set our size to the z-axis, we set that to our direction. I said distance, direction dot magnitude. So this will make a part with a fixed width and height, but with a length of direction dot magnitude. So this should work out pretty well. So let's now return our part. There we go. And we won't really need to use the return part, but it's just a good practice to have it there. Now, we need to make our laser fire function. This will be responsible for actually shooting the lasers, doing all the raycasting, and yeah. So we first need to find a direction variable. We will reuse this frequently throughout the loop that we will be creating for the fire loop. And the direction will be initially set to our position of our origin part, which brings me, so we have to make a parameter for our fire function. This will be the origin part that we will be firing from. So we have to, for the direction, we have to get the origin part dot cframe dot look vector, and we have to multiply it by self dot max distance. So this will be a vector in the direction of our look vector with the distance of our max distance. And now we need to make our origin. Origin is pretty simple. This will be the origin part dot position. So it'll start at the origin part dot position and have a direction of this, which is pretty good. And so it'll always be facing the front face. That's what look vector is. It'll be looking at the front face towards whatever. And now that we have made this preliminary code, let's actually make our origin part in our base plate. So I'm just going to make a simple part. I'm going to anchor it, move it up a little bit. And when you're doing stuff like this, make sure to go to your part, then surface, and then front surface, and you will know exactly where it'll be shooting from. So it'll be shooting from this face. I'm going to make it smaller, but then make it longer in the front face so we know which direction is the front face. And there we go. That looks good. So let's go back into our script, and we can continue on our fire function. So the next thing we need to find is our Recast parameters. So local Recast params equals Recast params dot new. There we go. So what this will be used for is the function workspace.raycast. It takes an origin, direction, and raycast params. And this is sort of similar to workspace find part on ray. The only difference is that it's stored in this raycast params. So what we want to do here is set raycast params dot filter descendants instances. We want to set this to a table that will be holding our laser beams folder. There we go. So this by itself won't really do anything. It'll make sense when we add this next statement. So it'll be raycast params dot filter type will be equal to enum dot raycast filter type dot blacklist. So what this will do is it will create our filter descendant instances, which is our laser beams folder, and it will blacklist it. So this will basically mean when the ray hits another laser, it will not reflect, because that wouldn't make sense. If a laser part hit another laser part, it should not reflect back off of it, because like the laser shouldn't reflect off of itself. That'd be stupid. So it'll just go straight through it. And that's only, you can only see this happening in very select cases, but it just makes it a little bit more realistic, so to speak. So now we can make our for loop. And this loop's going to be kind of weird because I tried to format it in the best way possible, but it just, like, there was no really good way to do it because we had to check conditions repeatedly. So we're going to make a for loop. So for reflections equals 1 self.maxDistance do. So this loop will run. It's not max distance, my bad. For reflections equals 1 self dot max reflections. There we go. Do. So this will repeat 50 times right now because max reflections is indeed set to 50. Let me zoom in a little bit. Sorry, I forgot to do that at the beginning. But that won't really check for other criteria that we need in our loop. So we're going to do that right now. So the first thing we need is the result. So local result will be equal to workspace raycast. And the parameters we will send are the origin, the direction, and the raycast params. So this is a raycast result, this variable right here. And it'll be used to find the position, the normal, like all the stuff that we need for our ray. And now we can just define our part. And this will be like the laser beam part. And this will be equal to self show beam, the origin. And this is a pretty interesting statement. Result and result.position minus origin or direction. And you may be asking, how can logic statements be in a normal function parameter and not in like an if statement? So these logical operators actually have pretty definitive functional properties. So the AND function returns the first result if it's false, or the second result. So if the first result's true, then it'll return the second result. So if result exists, if the result raycast result exists, because this workspace raycast function will create a ray, but if there is no part to be touched, then it will not be there. So result will be nil. And so if result is nil, then this AND function will return false or nil. And OR returns whichever parameter that it gets is true. So if result and result.position minus origin is false, then OR will return direction. So basically, you don't have to understand the specifics, but if result is true, or it like just exists, then we will return result.position minus origin. If result is false, then we will return direction. And this is just good for later when we just want to display the ray, but sometimes the ray might not have a result. And like at the end of the ray when it doesn't hit anything. So you don't have to understand it, but just know that it's there and it works. So now we have to check if the result is not there, then we need to break the loop, and that will be that. And the reason we're checking this is because the result won't be there once the laser does not hit anything. After it reaches past the max distance, it does not hit anything, result won't be there. So we want to stop it there. We don't want to keep on looping through nothing. But the reason we have to display this is so we don't have to put any extra statements below this for loop. I'm trying to make the for loop as inclusive as possible. And next, all we need to do is get the light vector. And this is also kind of weird because we have to get the unit vector of the result dot position, spelled that wrong, minus the part dot position dot unit. So it just gets the vector from our result to our part, which is up here. And now we can define our reflection vector. But actually, we can't really define a reflection vector because we have no reflection function. So let's do that right now. I'm going to go to the top of my script. Before all of these laser dot variables, I'm going to create a local function reflect. And this is going to take in a light vector and a normal vector. So I'm just going to say LV and then NV. So normal vector and a light vector. And then I'm going to return, this is just going to be a math thing. As I said in the showcase video, this is just a math function. You don't really have to understand it. It just does some math to get the reflection vector. So LV minus 2 times NV times LV dot normal vector. So it's going to be NV. So make sure to put the colon after LV light vector dot. This will get the dot product of LV and NV. So there we go. Our reflection function is done. Now we can go down here and set our reflection vector equal to reflect. And this will take in the light vector and the result dot normal. So let's do this. Light vector and result dot normal. There we go. So that's our reflection vector. And now we need to define the origin variable and our direction variable for the next iteration of the loop. So origin will be equal to the result dot position, so like the intersection of the ray and the part that it touches, and direction, oh, that's weird, and direction will be equal to the reflection vector, and the reflection vector is a unit vector, and this will be multiplied by self.maxDistance. There we go. So that is our for loop done. So it should work perfectly fine. And now we're only going to define one more function. This is going to be laser clear. And this is going to take our laser beam folder and just clear all children. This will be useful if you want a dynamic fire function. And I'm not going to show you how to do that in this video because it's pretty simple. All you do is make a while loop that fires a laser, then clears it, or then waits a certain amount of time, then clears it, then just fires again. So it just repeats that forever. So this is our module basically done. And it's pretty complex, so I won't be surprised if there's some errors, but I'm sure we can figure it out. So I'm going to go back into the workspace and create a script. And I'm going to zoom in, and I'm going to define my laser module equals require script.parent.laser. There we go. So this will require our laser module. I'm going to create a new laser, and this will be equal to laser module new. And I'm going to do laser fire. And we need an origin part, so I'm going to go to this part that I created earlier. I'm going to name this origin. I'm going to fire it with the script.parent.origin. So if I run this, theoretically a laser should come out. Look at that. So the laser comes out 50 studs. There we go. So now if I were to angle this down, laser should bounce. So look at that. The laser, this is the laser part, just for you to see it. It's kind of stuck inside of the block. Keep that in mind. It just bounces off of the floor. And so let's just do some more tests. So if we were to go and create another part that it can reflect off of, just make it tall and wide, and we can fire it again. You can see it bounces a few times and then goes back down. So you can play around with this as much as you want. It's a super cool system. And that's about it. So I hope you guys enjoyed this video. This is a fairly complex system, so I will make sure to put a Pastebin with all of the code for this module and description. And make sure to ask me if you have any questions because this is pretty complex. But I hope you guys enjoyed. In the last showcase, you guys asked me to make this tutorial, so this is the tutorial. I hope you enjoyed. Make sure to like and subscribe if you did. Make sure to comment any suggestions or questions or more tutorial video ideas down below. And I hope you guys have a nice day, and goodbye.